This is Softwareable Bytes. Hello and welcome to another episode of Softwareable Bytes. This is the show where I read to you articles and blog posts on subjects like software and cloud engineering and architecture, site reliability engineering, DevOps, and everything in between. If you are looking for software and cloud development services and training, check out softwareable.com. We help customers in their software and cloud journey, whether it's taking software from ideas to complete solutions, migrating existing systems to the cloud, or mentoring and training individuals and teams. We make it work for your needs. Go to softwareable.com, that's software without the E, IBLE.com to learn more. Today's episode is a continuation of the last episode. So if you are new here, it's better that you listen to the previous episode first. But if you all caught up, let's continue with part 2. What Developer Self-Service Shouldn't Look Like by Kaspar von Grünberg of humanitech.com. The take it all from the crew. My other example comes from a really large company that builds lots of stuff around cars and has thousands of developers. If you ask any developer about their central platform unit, they get angry if you're lucky. This unit has come to the conclusion that developers actually don't need that much choice and that they could make most decisions centrally for them. They've not only abstracted everything away from them, they've literally taken any room to respond to the specific needs of individual teams. Developers don't understand what goes on inside the black box platform that was built, and are totally dependent on the central platform team to increase functionality. In this case, there is literally no way to circumvent the default. Developers don't know what's happening under the hood. They have no idea how things turn out. They simply don't trust the system. This only exacerbates the fact that in reality, in application development, it is already hard to forecast what default the team will require. To believe that a platform team can cover 100% of cases is naive. What happens is that developers first wait for new functionality. The platform team doesn't deliver, then they simply revolt and abandon the platform altogether. You again win nothing. The cognitive load trade-off. The two examples above are extremely negative and present both extremes. But how do you think about this the right way? How do you determine how much to throw at your team versus how much you abstract away? I've developed a model to help you structure your thoughts around this, and I call it the cognitive load trade-off. Because this is exactly what it comes down to. Cognitive load. Let me explain. It's probably fair to assume that developers are somewhere on the right of the bell curve of IQ distribution. In plain words, they are smart and of course, they are able to figure out how to run Terraform at scale, if they have to. But while they are becoming IAC wizards, they fall back on their area of specialization. It's not what their managers and the market pays them for. The decision that we have to take is how much cognitive load we want to throw at them. More complexity, more cognitive load. The only way to determine this is through good old communication. That's the single most important component here. How deep do they want to go? What do they feel comfortable with? How much time can we allocate for learning new stuff? We can think about this theoretical too. Simply map cognitive load against the complexity of the setup. The more complex your setup, the higher the cognitive load. If you would need to map our examples above, the Heroku setup would be on the left. The setup the SRE geniuses of the first example came up with is on the right side. Huge amount of cognitive load, huge amount of complexity for the developers to handle. How much cognitive load somebody is willing to handle varies from team to team. Well-run engineering teams communicate enough to understand the team's, or even the individual's, preference for cognitive load. Beyond this load, they build opaque abstractions, golden paths, that help developers understand what's going on under the hood while limiting further cognitive load. Golden paths, not cages. Let's assume we've figured out the amount of cognitive load our developers can handle while doing everything we expect from them. That means the rest has to be abstracted or handled for them. In our second example, we've seen the disastrous effects of high level of abstraction. The key here is to go for golden paths over golden caves, and to constantly keep communicating. I really can't stress this enough. A golden path is about abstracting without abstracting. Developers understand what's under the hood. They could go low level. You don't keep them from doing this. All you do is give a guarantee that things are easier if you stick to the paths. What we see in the data is that 97% of developers stick to a golden path once established, following the social contract that staying on the path makes the setup more scalable and easy to operate for everybody. Jason Warner, CTO at GitHub, explained this well when he detailed out how they introduced their self-service setup, freed people from PagerDuty, and made them go fast without restricting anybody from going low level. GitHub engineers are arguably among the best in the world. To quote Jason further, we understand these concepts better than anybody on the planet. In the end, we invented 90% of all concepts we use today. That's self-confident, but true. Not even at GitHub, developers interpret "you build it, you run it" as developers doing everything. If they don't do it that way, you shouldn't either. And just to reiterate on this one, if you communicate, you win. You have to treat developers as users. You have to iterate with them. You have to explain why the golden path makes sense and why they should use it for the good of everybody. And to end with some shameful self-advertisement, but one I deeply believe, internal developer platforms can help you build self-service setups that make wonderful golden paths. They help you abstract without keeping things away. They let you expose just the right amount of cognitive load for every single developer. You just listened to part 2 of What Developer Self-Service Shouldn't Look Like by Kaspar von Grünberg of humanitech.com. This was an interesting read. I can relate to the examples in this article, some I even encountered or been in the presence of. It's hard to escape the division, even in teams designed to eliminate it, for example, when making the ops engineer part of the team. Just because the engineer is in the team now doesn't mean the walls were dejected. As Kaspar pointed out, communication is the key. See if the developers are comfortable with a tool before introducing it fully. Maybe introduce that as a POC in a small part of the system that has preferably already been handled in a different way at the time, rather than with completely something new. For example, if a development team requires a new database instance for a new service, and there was already a script that does that for them, if you are thinking of introducing Terraform, introduce it instead of that script, and try to make it as easy as possible for them to work with it. In other words, document the process, help them in the beginning, etc. Then measure how independently they could perform the task later on. And if that was a success, then you can gradually introduce more and more of that. It's easy to argue sometimes and get lost in the argument for something we introduced that we think is the perfect fit for the situation at hand. And it could be from a technical perspective. But we discard how others think about it and if they are capable of dealing with it or even comfortable. I once introduced Helm to a team and the developers didn't feel comfortable handling Helm charts. They were facing issues and they kept pulling me in every time something is wrong. There was my hint. Helm might have been a fit from the technical perspective, but not for that team, especially when a negative association with the tool has already been formed. Okay, let's now check the tool of the day. kubectl get network policy will provide you with a list of all the network policies in a certain namespace, which provides little information about the pods they apply to and the rules they specify. You usually have to look at the details of each network policy to understand their inner workings. This is where today's tool helps. kubectl Swift NP. It's a kubectl plugin for rendering details of network policies. It provides detailed information such as the selected pods, ingress and egress policy, ingress and egress rule across multiple namespaces. Search for kubectl Swift NP on GitHub or check the link to it in the description of this episode. And that should do it for another episode of Softwareable Bytes. Have a great rest of your day, and I'll see you here again in the next episode.